Welcome everyone. It is 3 p.m. and it's time for the Server Room Show. This is episode 81. Today I will talk about a piece of the dawn of the modern internet age called BBS, the Bulletin Board System. So just very briefly of what it means before diving into its history and to know more about it. I have a lot of material to go through, so I don't know, maybe I will fit it into an episode, maybe I will not. As always, you will figure it out the same time when I do, as these recordings are not practiced in advance. I never time myself going through it and see when I have enough material, so to say. I prepared the material, the text in advance indeed, but I never go like on a practice session to time and to see, I already have, let's say, 20 minutes worth of material. I need to add some more. So I try to do this a little bit like cooking, without actually measuring the ingredients with a scale. I just use my eyes and my judgment and try to say, okay, that must be enough for one episode, for this 30-minute block I'm working with. So BBS is an acronym short for Bulletin Board System, or sometimes called and referred to as CBBS for Computer Bulletin Board Service. A computer server running software that allows users to connect to the system using a terminal program. Once logged in, the user can perform functions such as uploading and downloading software and data, reading news and bulletins, and exchange messages with other users through public message boards and sometimes via direct chatting. So the BBS, precursor to the public bulletin board system, a precursor to the public bulletin board system was community memory, started in August 1973 in Berkeley, California, same place where BSD came from. Useful microcomputers did not exist at that time, and modems were both expensive and slow. Community memory therefore ran on a mainframe computer and was accessed through terminals located in several San Francisco Bay Area neighborhoods. The poor quality of the original modem connecting the terminals to the mainframe prompted community memory hardware person Lee Felsenstein to invent the penny whistle modem, whose design was highly influential in the mid-1970s. Community memory allowed the user to type messages into a computer terminal after inserting a coin, and offered a pure bulletin board experience with public messages only, no email or other features. It did offer the ability to tag messages with keywords which the user could use in searches. The system acted primarily in the form of a buy and sell system, with the tags taking the place of the more traditional classifications. But users found ways to express themselves outside these bounds, and the system spontaneously created stories, poetry, and other forms of communications. The system was expensive to operate, and when their host machine became unavailable and the new one could not be found, the system closed in January of 1975. Similar functionality was available to most mainframe users, which might be considered a sort of ultra-local BBS when used in this fashion. Commercial systems expressly intended to offer these features to the public became available in the late 1970s and formed the online service market that lasted into the 1990s. One particularly influential example was Plato, which had thousands of users by the late 1970s, many of whom used the messaging and the chat room features of the system in the same way that would become common on BBSs. Early modems were generally very simple devices using acoustic couples to handle telephone operation. The user would first pick up the phone, dial a number, then press the handset, into rubber cups on the top of the modem. Disconnecting at the end of a call required the user to pick up the handset and return it to the phone. Examples of direct connecting modems did exist, and these often allowed the host computer to send it commands to answer or hang up calls, but these were very expensive devices used by large banks and similar companies. With the introduction of microcomputers with the expansion slots like the S100 bus machines and Apple II, it became possible for the modem to communicate instructions and data on separate lines. A number of modems of this sort were available by the late 1970s. This made the BBS possible for the first time, as it allowed software on the computer to pick up an incoming call, communicate with the user, and then hang up the call when the user logged off. The first public dial-up BBS was developed by Ward Christensen and Randy Suess. According to an early interview when Chicago was snowed under during the Great Blizzard of 1978, the two began preliminary work on the Computerized Bulletin Board System, or CBBS. The system came into existence largely through a fortuitous combination of Christensen having a spare S100 bus computer and an early Hayes internal modem, and Sue's insistence that the machine be placed at his house in Chicago, where it would be a local phone call for more users. Christensen patented the system after the cork board his local computer club used to post information like I need a ride or something like that. CBBS officially went online on the 16th of February 1978. CBBS, which kept account of callers, reportedly connected 253,301 callers before it was finally retired. Let's talk about the smart modem from Hayes. A 300 baud smart modem from Hayes, which led to an initial wave of early BBS systems. It's quite a handsome device, nevertheless. A key innovation required for the popularization of the BBS was the smart modem manufactured by Hayes microcomputer products. Internal modems like the ones used by CBBS and similar early systems were usable, but generally expensive due to the manufacturer having to make a different modem for every computer platform they wanted to target. They were also limited to those computers with internal expansion and could not be used with other useful platforms like video terminals. External modems were available for these platforms, but required the phone to be dialed using a conventional handset, making them unable to accept incoming calls without manual intervention. Internal modems could be software controlled to perform both outbound and inbound calls, but external modems had only the data pins to communicate with the host system. Hayes' solution to the problem was to use a small microcontroller to implement a system that examined the data flowing into the modem from the host computer, watching for certain command strings. This allowed commands to be sent to and from the modem using the same data pins as all the rest of the data, meaning it would work on any system that could support even the most basic modems. The smart modem could pick up the phone, dial numbers, and hang up again, all without any operator intervention. The smart modem was not necessary for BBS use, but made overall operation dramatically simpler. It also improved the usability for the caller, as most terminal software allowed different phone numbers to be stored and dialed on command, allowing the user to easily connect to a series of systems. The introduction of the smart modem led to the first real wave of BBS systems. Limited in both speed and storage capacity, these systems were normally dedicated solely to messaging, both private email and public forums. File transfers were painfully slow at these speeds, and file libraries were typically limited to text files containing lists of other BBS systems. These systems attracted a particular type of user who used the BBS as a unique type of communications medium. And when these local systems were crowded from the market in the 1990s, were crowded from the market in the 1990s, their loss was lamented for many years. About the higher speeds and commercialization, speed improved with the introduction of 1200 bits per second modems in the early 1980s, giving way to 2400 bits per second fairly rapidly. The improved performance led to a substantial increase in BBS popularity. Most of the information was displayed using ordinary ASCII text or ANSI art, but a number of systems attempted character-based graphical user interfaces, which began to be practical at 2400 bit per second. There was a lengthy delay before 9600 bit per second models began to appear on the market, and 9600 bit per second was not even established as a strong standard before V32 bis at 14.4 kilobit per second took over in the early 1990s. This period also saw the rapid rise in capacity and dramatic drop in the price of hard drives. By the late 1980s, many BBS systems had significant file libraries, and this gave rise to leeching, users calling BBSs solely for their files. These users would tie up the modem for some time, leaving less time for the other users who got busy signals. The resulting upheaval eliminated many of the pioneering message-centric system. This also gave rise to a new class of BBS systems dedicated solely to file upload and downloads. These systems charged for access, typically a flat monthly fee compared to the per hour fees charged by Event Horizon BBS and most online services. A host of third-party services sprang up to support these systems, offering simple credit card merchant account gateways for the payment of monthly fees and entire file libraries on compact disc that made initial setup very easy. Early 1990s editions of BoardWatch were filled with ads for single-click install solutions dedicated to these new sysops. While this gave the market a bad reputation, it also led to its greatest success. During the early 1990s, there were a number of mid-sized software companies dedicated to BBS software, and the number of BBSs in service reached its peak. Towards the early 1990s, the BBS industry became so popular that it spawned three monthly magazines: BoardWatch, BBS Magazine, and in Asia and Australia, Chips and Bits magazine, which devoted extensive coverage of the software and technology innovations and the people behind them, and listings to US and worldwide BBSs. In addition, in the US, a major monthly magazine, Computer Shopper, carried a list of BBSs along with a brief abstract of each of their offering. And graphical user interfaces. Through the late 1980s and early 1990s, there was considerable experimentation with ways to improve the BBS experience from its command line interface roots. Almost every popular system improved matters somewhat by adding ANSI-based color menus to make reading easier, and most also allowed cursor commands to offer command line recall and similar features. Another common feature was the use of autocomplete to make menu navigation simpler, a feature that would not reappear on the web until decades later. A number of systems also made forays into graphical user interfaces based interfaces, either using character graphics sent from the host or using custom graphical user interfaces based terminal systems. The latter initially appeared unsurprisingly on the Macintosh platform, where Telefinder and First Class became very popular. First Class offered a host of features that would be difficult or impossible under a terminal-based solution, including bidirectional information flow and non-blocking operation that allowed the user to exchange files in both directions while continuing to use the message system and chat, all in separate windows. Skypix featured on Amiga a complete markup language. It used a standardized set of icons to indicate mouse-driven commands available online and to recognize different file types present on BBS storage media. It was capable to transmit data like images, audio files, and audio clips between users linked to same BBSs or offline if BBS was in the circuit of FidoNet organization. On the PC, efforts were more oriented to extensions of the original terminal concept, with the graphical user interfaces being described in the information on the host. One example was the remote imaging protocol, essentially a picture description system, which remained relatively obscure. Probably the ultimate development of this style of operation was the dynamic page implementation of the University of Southern California BBS, the USC BBS, by Susan Biddlecombe, which predated the implementation of the HTML dynamic web page. A complete dynamic web page implementation was accomplished using TBBS with a TDBS add-on presenting complete menu system individually customized for each user. The rise of the internet and the decline of BBS, the demand for complex ANSI and ASCII screens and larger file transfers, text available channel capacity, which in turn propelled the demand for faster modems. 14.4 kilobit per sec modems were standard for a number of years, while various companies attempted to introduce non-standard systems with higher performance, normally about 19.2 kilobit per sec. Another delay followed due to a long V34 standards process before 28.8 kilobit per sec was released, only to be quickly replaced by 33.6 kilobits per sec and then 56 kilobit per sec. These increasing speeds had the side effect of dramatically reducing the noticeable effects of channel efficiency. When modems were slow, considerable effort was put into developing the most efficient protocols and display systems possible. Running a general purpose protocol like TCP/IP over a 1200 bit per sec modem was a painful experience. With the 56 kilobit per sec modems, however, the overhead was so greatly reduced as to be unnoticeable. Dial-up internet service became widely available in 1994. The must-have option for any general use operating system by 1995. These developments together resulted in the sudden obsolescence of bulletin board technology in 1995 and the collapse of its supporting market. Technically, internet service offered an enormous advantage over BBS systems, as a single connection to the user's internet service provider allowed them to contact services around the world. In comparison, BBS system relied on a direct point-to-point connection, so even dialing multiple local systems required multiple phone calls. Moreover, internet protocols allowed that same single connection to be used to contact multiple services at the same time, say download files from an FTP library while checking the weather on a local news website. In comparison, a connection to a BBS allowed access only to the information on that system. According to the FidoNet nodelist, BBSs reached their peak usage around 1996, which was the same period that the World Wide Web and AOL became mainstream. BBSs rapidly declined in popularity thereafter and were replaced by systems using the internet for connectivity. Some of the larger commercial BBSs, such as Max Megabyte and Exec PC BBS, evolved into internet service providers. The website textfiles.com serves as an archive that documents the history of the BBSs. The historical BBS list on textfiles.com contains over 105,000 BBSs that have existed over a span of 20 years in North America alone. The owner of textfiles.com, Jason Scott, also produced BBS, the documentary, a DVD film that chronicles the history of the BBS and features interviews with well-known people, mostly from the United States, from the heyday BBS era. In the 2000s, most traditional BBS systems migrated to the internet using Telnet or SSH protocols. Between 700 and 800 are thought to be active in 2020, fewer than 30 of these being of the traditional dial-up modem variety. We can start to talk about the software and hardware, and I think I will have some material left for a second episode. I might need to couple the remainings of this episode with an additional thing, and it will pan out. Okay, you will see. So the software and hardware, unlike modern websites and online services that are typically hosted by third-party companies in commercial data centers, BBS computers, especially for smaller boards, were typically operated from the SysOps home. As such, access could be unreliable, and in many cases only one user could be on the system at a time. Only larger BBSs with multiple phone lines using specialized hardware, multitasking software, or a LAN connecting multiple computers could host multiple simultaneous users. The first BBSs used homebrew software, quite often written or customized by the SysOps themselves, running an early S100 bus microcomputer systems such as the Altair 8800, IMSA 8080 and Chromemco under the CP/PM operating system. Soon after, BBS software was being written for all of the major home computer systems of the late 1970s era, the Apple II, Atari 8-bit family, Commodore and the TRS-80 being some of the most popular. A few years later, in 1981, IBM introduced the first DOS-based IBM PC, and due to the overwhelming popularity of PCs and their clones, DOS soon became the operating system on which the majority of BBS programs were run. RBBS PC, ported over from the CP/PM world, and Fido BBS, created by Tom Jennings, who later founded FidoNet, were the first notable DOS BBS programs. Many successful commercial BBS programs were developed for DOS, such as PC Board BBS, Remote Access BBS, and Wildcat BBS. Some popular freeware BBS programs for DOS included Teleguard BBS and Renegade BBS, which both had early origins from leaked WW4 BBS source code. There were several dozen other BBS programs developed over the DOS era, and many were released under the shareware concept, while some were released as freeware, including Iniquity. BBS systems on other systems remain popular, especially home computers, largely because they cater to the audience of users running those machines. The ubiquitous Commodore 64, introduced in 1982, was a common platform in the 1980s. Popular commercial BBS programs were Blueboard, Ivory BBS, Color 64, and CNET 64. In the early 1990s, a small number of BBSs were also running on the Commodore Amiga. Popular BBS software for the Amiga were ABBS, AMI Express, CNET, Stormforce BBS, Infinity, and Tempest. There was also a small faction of devoted Atari BBSs that used the Atari 800, then the 800 XL, and eventually the 1040 ST. The earlier machines generally lacked hard drive capabilities, which limited them primarily to messaging. MS-DOS continued to be the most popular operating system for BBS use up until the mid-1990s and in the early years. Most multi-node BBSs were running under a DOS-based multitasker, such as DeskView, or consisted of multiple computers connected via a LAN. In the late 1980s, a handful of BBS developers implemented multitasking communications routines inside their software, allowing multiple phone lines and users to connect to the same BBS computer. These included Galacticom's major BBS, later Word Group, Airsoft, the breadboard system, TBBS, and Falcon. Other popular BBSs were Maximus and Opus, with some associated applications such as Binkley term being based on characters from the Berkeley breaded cartoon strip of Bloom County. Through most BBS software had been written in BASIC or Pascal, with some low-level routines written in assembly language, the C language was starting to gain popularity. By 1995, many of the DOS-based BBSs had begun switching to modern multitasking operating systems, such as OS2 of IBM, Windows 95 from Microsoft, and Linux. One of the first graphics-based BBS applications was Excalibur BBS, with a low bandwidth applications that required its own client for efficiency. This led to one of the earliest implementations of electronic commerce in 1996, with the replication of partner stores around the globe. TCP/IP networking allowed most of the remaining BBSs to evolve and include internet hosting capabilities. Recent BBS software such as Synchronet, Mystic BBS, LE-BBS, Dock, or Wildcat BBS provide access using the Telnet protocol rather than dial-up, or by using legacy DOS-based BBS software with a fossil to Telnet redirector such as NetFOS. I will stop here now, and what is left from my article I prepared regarding BBS, I will put it into a part 2 episode, and most probably I will couple with another topic I wanted to discuss anyway, which is Usenet. So let's say that episode 82 next week is going to be this part 2 of BBS and what's left of that material, and I will complete it with some about Usenet, which they have their similarities of sort, but they are still different systems, so to say. Thank you very much for listening, and see you